All right, CNT120, Chapter 6. We're going to take a look at some aspects of wireless networking. In this chapter, we're going to cover kind of a lot of the basics and some of the details of standards, as well as implementing a Wi-Fi network and a little bit about troubleshooting. So let's dive in. Things we need to remember, there's some general stuff they're going to cover here at the beginning of the chapter. Some characteristics of wireless transmissions. We need to remember wireless networks are transmitting their signals through the air through RF or radio frequency waves. The rest, though, anything layer 3 and above, is going to be identical to our wired networks. So IP, TCP, those kind of things are all going to be identical as we move up through the layers. It's really only that layer 1 and 2 that are different for when we compare wireless to wired networks. The challenge is, as we're transmitting signals through the air, through the atmosphere, there's lots of things that affect that signal. So one of the first things they mention is our wireless spectrum. The wireless spectrum, there's a finite number of frequencies to use for communication purposes, if you will. That radio spectrum, that wireless spectrum, spans from 9 kilohertz up to 300 gigahertz that we are focusing on. Any of our wireless communications are going to fall into one slot in that spectrum. Here in the United States, we have the SEC, the FCC, Federal Communications Commission, that oversees the wireless spectrum and what gets used in what frequency range, if you will. That way you don't have two radio stations broadcasting on the same frequency in the same town. Things like, wireless access points are using a certain frequency here and nothing else is using that. So we don't have, it's minimizing the chance of interference, if you will. The ITU, which is a subgroup of the UN, United Nations, oversees your international, any signals crossing borders, that sort of thing. So here I just grabbed a picture of the electromagnetic spectrum, and as you see here, pretty much anything electromagnetic waves is represented on here, anything from radio the whole way up to X-rays, etc. Our focus is really down here on this bottom end, this radio spectrum end, where we have broadcast and wireless as well as up to microwave satellite communication, if you will. That's our focus on when we talk wireless communications. If I take that piece, if I take this piece down here and break it out further, this is what the book has in there for you, showing you where these different technologies fall in the frequency band. And it's pretty easy to see that this was like organized and laid out that certain things happen in certain bands. Starting down here, RFID, AM radio, near field communication. Here's your Z-Wave home automation, FM radio, cellular, another slot of RFID. We have some satellite communication here. There's also satellite communication up here. Cellular here. Here's our Wi-Fi, Bluetooth, that sort of thing. The other band of Wi-Fi up here. So it's all allocated out as to these devices operate in this frequency band, etc. And that's all done by FCC here in the United States, but overseen by ITU globally, if you will. Here's a chart that kind of has all of those technologies in and quick references to all those. But the book breaks out kind of each of these technologies in their own little paragraph. So we'll take a look at each one of these, at least the highlights of each one of these technologies. As I always say, when we have this many technologies to look at, familiarity is the key. Familiarity is the key. All right, the book also mentions at this point the Internet of Things. We have all kinds of things that can be connected to a network. The Internet of Things is all those little devices like our home automation, our smart energy thermostats, multimedia speakers, smart speakers, security cameras, industrial sensors, and those sorts of things in a manufacturing plant. These kind of things that we wear or have in our homes. These are all the things that can be connected to a network, and they're all going to fall into one of these technology bands that we're going to talk about. So let's take a look and kind of survey these real quick. RFID, radio frequency identification. RFID, we have a lot of times this gets used for inventory management, also for contactless payment. So here we have a tag on a device that's going to contain a little bit of information, and that can get scanned, and we can pull information from that. So sometimes we have this on inventory. Sometimes you actually have it on things like your pet. You might actually have a chip, implanted right, kind of by the neck of your pet, and that has enough information to let you know the dog's name, dog's address, and a phone number in case the dog is lost. These would all be examples of RFID, and that chip is having just enough information that when we scan it, we can pull from that. Things like your Easy Pass in your car would be an example of RFID. Inventory management in a manufacturing plant, moving product in and out would be examples. Here's another one showing you sensors by the loading dock, tags on products or tags on boxes. If you do a little bit of history reading, places like Walmart and other big big retail stores did research on RFID tags putting on products, and whether they could get a system in place where you put the 5 or 6 items that you wanted in a bag, and as you walked out the door, it would scan those products. It would scan the tags on the products, and then scan like a tag on your key ring, and it would say, okay, Doug is buying these 4 products, and here's Doug's payment on his key fob, and literally charges those products I'm buying to my keyring fob, and I could literally just walk out the door with those products, and it would charge my account for them. Places did research on that. Walmart was one of the big ones that did research on that. They found out, unfortunately, that some of these tags can be prohibitive in cost. You might have a $2 or $3 tag on a $1 item, a pack of gum. So it's kind of prohibitive to have all of these tags on all the products when it actually sometimes is more expensive than the product itself. But the concept is there. The idea was there. But it does get used in places like shipping, warehousing, moving product around, and you might even have it in places like hospitals to keep track of items like IV poles or IV machines, or even beds. Where is this bed? Where is this piece of imaging equipment? And you can keep track of things that way, inventory-wise. RFID can be used in credit cards, that sort of thing, but there is a danger of skimming information from them, whether it be on the machine itself, putting a little fake cover over that you're going to skim information off, or literally skimming from people's pocket. So newer chips actually have a EMV chips in to help with that. It almost looks like a little circuit board on there on your credit card, and that actually helps with that RFID skimming issue. Another technology, near-field communication. This is another form of RFID made for very short distances, and this can be used for like payment, or as you see here, business cards, swapping business card photos, that sort of thing, between devices. So here's where you might have the whole, I put my phone near the payment device and say, okay, here's my account information, charge my account for these 2 shirts or 2 shoes, 2 pairs of shoes or whatever that I bought. Also, things like badges and so forth, I need to be super close, and it's like, oh yes, okay, this is Doug Brown, he's allowed in this room, or hey, this is Doug Brown, he's allowed to ride this ride at blah amusement park. Z-Wave, a form of home automation, or smart home, if you will. Z-Wave, you have a controller like a hub that devices in your house communicate with, and these could be devices scattered around your house connected to light bulbs and switches, and they can connect to that communication hub, and things like your smartphone could control that, or things like your voice on a speaker could control turning a light on or off. These all kinds of products here that can be used to communicate between the light switch and the hub and my phone, and I can be communicating with those devices in my house to turn them on, turn them off. A form of smart home or home automation, if you will. Just showing you some samples here of things that could be installed. ZigBee is similar, but it's ideal for industrial. Where I have maybe a manufacturing plant where I need to monitor my sensors, my temperature sensors, my liquid height sensors, that sort of thing in my facility. So this is more aimed towards industrial versus Z-Wave for home. So here I think I have a bunch of examples of products, things that can be installed for sensing levels, temperatures, that sort of thing in your facility. So depending what you're manufacturing, what you're storing, what you're warehousing, I might be paying attention to the temperature, the humidity level, the liquid level, etc. Bluetooth. A lot of us are very familiar with this for connecting phones to a smart speaker, phones to your car for audio, call purposes, etc. Might even be headsets connecting to your phones. So a lot of us use Bluetooth for various reasons there. This comes from a medieval king of Denmark named Harald Bluetooth, fought to, kind of unite tribes. So this name was used in honor of, Bluetooth was used in honor of Harald Bluetooth. Operates in basically the 2.4 gigahertz band. It's gonna, when it communicates, it hops around frequencies in that band to try to avoid maybe interference or conflict with other devices in the area. And we have all kinds of things that are used for Bluetooth: headsets, smartwatches, phones to cars, phones to smart speakers, etc. My phone to my stereo in my house, etc. Ant Plus. This was developed by Ant Wireless, bought out and owned by Garmin. It's kind of open source. It's proprietary, but it's also open source, used by a number of manufacturers. This gets used a lot for your heart rate, heart monitors, activity monitors, things like that, to sync up with your smartphone. So sensors on your bike, maybe heart rate sensors that you're wearing on your watch or whatever, would be able to communicate with your phone. All kinds of things that could communicate up for usually those purposes. Infrared. Infrared we think of, kind of in the early days of remote controls, and it kind of went by the wayside for a while, but it has a new life in the Internet of Things. So infrared can be used for sensing of. We think of it as remote controls, but can also be used in sensing of things like game controllers. If you think back to like the first Wii, the bar up by the TV and your remote were communicating with infrared. That's why you had to have that line of sight between them. Well, in an industrial environment, they can be used for sensing liquid levels of. Also things like heart rate on your health monitors. That is actually looking at your blood flow, that sort of thing, in your finger, in your arm, etc. So, and here is sensing for maybe products moving on a manufacturing plant. So many bottles go by, triggers this, etc. Or maybe, it senses a full bottle, so it kicks it out, or an empty bottle and it kicks it out, etc. So sensors for. So Internet of Thing, infrared has some new life. All right, we will come back in the next one and start talking about some channel management.